Hi everybody, I hope that you can hear me. Sorry for the, again, as Martin said, for the short delay before we could get started. I'm very glad to be able to present to you today, and I hope that you enjoy this webinar. What we're going to be looking at is CubeSat antenna design. And what I thought to start with is just spend some time looking at just some concepts around CubeSats, where they're used, what they are, why they're used, and then just one or two of the complications that they have, and then just mention a couple of the trends, just so that we can paint the picture that we're working in, and then we will actually start looking at the antennas. And just particularly, we're going to look at two examples, and the first example that we're going to look at is sort of a patch array design, where the idea is that we would like to make a patch array that is semi-transparent or that is able to allow light through, so that we can reuse some space on top of solar panels. And the second example is that we will look at the design of a feed horn for a deployable reflector that will be used on a CubeSat. And the last thing that we'll look at, just mention some of the concepts about some multi-physics and co-design, which are sort of hot topics at the moment. So let's get going talking about some of the CubeSat concepts. And the first important thing is to mention is that CubeSats are not a new thing. It's in fact a very old idea. And there is probably the first small or CubeSat that ever existed, and it was only 4 years after Sputnik, which is the well-known satellite. And this CubeSat actually fulfills a lot of the requirements of CubeSats. It was pretty cheap, about $63 to build. It only operated for about 3 weeks, and it was about 10 kilograms in weight and sort of the size of a shoebox. But the important thing was that it had a really simple functionality. It was just transmitting a Morse code chirp. Now, if we look at more conventional satellites that we're used to today, they're much more complex systems than that. They're typically very high cost. They're used for a very long time. And they have very demanding requirements. They take years to develop. And quite an important fact is they have a very high power usage. But the biggest issue is that they're big and they're heavy.